guys, so it's time for us to practice graphing the lines that we have been working on. You already know how to find a slope, how to find different intercepts. Now I'm going to show you some quick ways to draw a line given either the formula or 2 points. Now let's start with the slope-intercept form. Let's say in the first example, we are going to deal with a line denoted in the slope-intercept form, so mx plus b. And let's say we have a line that goes like this, 2x plus 3. So whenever you are working with the slope-intercept form and you want to graph a line, you don't need to do a table, right, of plugging different x values and different y values. What you can do here is basically find x and y intercept and draw a line through these 2 points. So to find y-intercept, we're going to make x equals 0, and that is simply 3. So x is 0. Actually, let me label our coordinate system right here. So here we have x values, here we have y values. So our y-intercept is when x is 0 and y is 3. So 1, 2, 3. That's our y-intercept. Now x-intercept is when y is equal to 0. So we are going to make our right side equal, our left side equal to 0, and right side remains the same. And let's just solve for x. So we'll subtract 3 from both sides, and we end up with -3 equal to 2x. Let's divide everything by 2, and we have -3 over 2 is equal to x. So -3 over 2, that's equal to -1.5. So it will be exactly halfway between 1 and 2. I'm sorry, -1 and -2. So if that's -1 and that's -2, this is going to be exactly in between. And now all you have to do is connect these 2 points. We actually fix that. Okay, so that's how you graph line when you are working with the slope-intercept form. Second way, you can have the point-slope formula or simply 2 points. So let's say we have the following 2 points. Well, first of all, let's not forget to label our coordinate system about what is what. And let's say we have point A equal to 2 and 3, and point B equal to 1 and let's see, negative. Actually, I'm gonna do 5. Why not? Okay, so if you're given 2 points, all you have to do is find them in the coordinate system. So I'm going to start with point A. X value is 1, 2, so that's the x value. Y value is 3. It's 1, 2, 3. And I'm going to find where these 2 intersect. And that's the point in the coordinate system. If you are using graphing papers for your notes, that's even simpler. It's just easier to trace it because you can use each single square as 1 unit of measurement. Okay, let's do point B with different colors. So x value is 1 and y value is 5. So that's 3, that's 4, and that's 5. So once again, you want to trace it. And it seems it's going to be right where y is. And once again, all you have to do that's left is to connect these 2 points or draw a line through them. Now notice that if we graph it without finding the slope, we can kind of determine what's happening with the slope. So in this case, right, the difference in run is equal to 1. The difference in rise is equal to 2. And since it's decreasing, right, it's decreasing with 2/1 ratio, so we can conclude that the slope is equal to -2/1, which is just -2. That's not a clever way of finding the slope graphically without doing any calculations if you're given 2 points. Now for the third example, obviously let me not forget to label our coordinate plane with x-axis and y-axis. Let's consider a standard form. Standard form, which is ax plus by is equal to c. Now, I'm sure there's a way of using the standard form in an efficient way to kind of like know where to put a certain point or whatnot. But what I recommend whenever you're working with the standard form is to transition it first into the slope-intercept form, which is y is equal to mx plus b. And that's what we're going to do. We're going to have 2x plus 3y is equal to, let's say, 9. Okay, so let's start moving some things around. First, let's subtract 2x from both sides. So we are going to have 3y equal to 9 minus 2x. Now let's divide everything by 3, and at the same time I'm going to switch the order on the right side. So we have y on its own, and then we have -2/3 plus 9/3 is just 3. And we know our intercept right away. That's our y-intercept because, oh, I forgot about x. When we make x equals 0, we just end up with 3. So when x is 0, it's going to be 1, 2, and 3. So that's our, oh, actually it should go the other way. Let me go back. Okay, so when x is 0, y is 1, 2, 3. So that's our y-intercept. Now let's find our x-intercept by making y equal to 0. So I'm going to add 2/3x to both sides, so we'll have positive 2/3x is equal to 3. And I'm going to multiply both sides by 3/2 to get rid of this fraction. And I end up with just x because these cross out. And on the other side, I end up with 9/2, which is 4.5. Okay, so when y is 0, I end up with 4.5. So it's, let me actually label that in green. It's 1, 2, 3, 4. That's 5. So 4.5 will be right in between. And once again, lastly, all we have to do is connect these two dots. I know this line is not exactly straight, but you get the idea. So this is y equal to -2/3 x plus 3 with a slope. Oh, bless me once again. We have 0, positive 3, and we have 4.5, comma 0. So that's how you graph lines using different methods. Now, if for some reason you forget how to use the slope-intercept form to find y-intercept and x-intercept, you can always do a table. You can always do a table and start plugging in arbitrary values for x and y. So using this example, right, 2x plus 3, we just need to find 2 points and connect them. I'm going to plug in 1 for x, and 2 times 1 is 2 plus 3, that's equal to 5. And for the second point, I'm going to use 3. So 2 times 3 is 6 plus 3, that's equal to 9. And now I have 2 points, 1 comma 5 and 3 comma 9. And I can graph it. They're gonna be exactly on the same line. If you don't believe me, just watch. So first we're going to pick the first point, which is 1. Actually, I'm using the same color. 1 and 5. So 1, 2, 3, 4, and 5. This will end up somewhere over here. So we can just keep extending that line. And the second point is 3, which is 2 and 3. And we're gonna go up to 9. If this is 5, then we have to go much higher. 5, 6, 7, 8, 9. And we're going to end up somewhere over here. So different points, same line, different method, same graph. We just extended that a little bit north into the y and x direction.